Yeah, in this tutorial we are going to cover Pandas series. So Pandas series is basically a one-dimensional labeled array. We can imagine a series is just like a column in an Excel sheet or a column in a database table. So one thing to notice, the labels in the series need not to be unique, but the thing is that those labels should be of hashable type. So we can have labels as integers or as well as strings. So to start with, we import pandas library using the normal convention. Import pandas as PD. PD is the normal convention that we use to represent pandas. Okay. Now the version I'm using is 1.0.3. I'm importing NumPy library also. So let's create a first series. So the syntax is pd.series, and then we specify the data, that this is the data using which we are going to build the series. And then it creates let's say we are creating a series of 7 colors of, and the output is into a rainbow. So we're creating a rainbow series which is having 7 colors, so we can check the data type of rainbow. So if we run type rainbow, we will get the data type of this object which says it's a series, pandas series. Now so whenever a series gets created, and if we are not specifying any index labels to it, that is we are just passing the data to it, then by default it creates the index starting from 0 to up to the number of elements we have, -1. Yeah. So in this case, since we did not specify any index, so if we check the index of this particular series, rainbow series, then we say like rainbow.index, and it says that okay, this index is starting from 0 and goes up to 7, which is exclusive, and the step is 1, that is it increasing by 1. So to find out whether the elements of a series are unique or not, we can use is underscore unique attribute. So we'll say rainbow.is unique. True, it means all the elements of this particular series are unique. So how do we access individual elements of a series? So just like in any list or Python list or arrays, NumPy arrays, okay, we specify the indexes within the square bracket. So we give the starting index and colon, and then the ending index. Just to note that the ending index value that we specify is exclusive. So if I'm saying rainbow 0:3, it means return all the values which are at index from 0 to 2, because 3 is exclusive. So within the rainbow, we have colors at index 0, 1, and 2 as violet, indigo, and blue. So these colors get returned by this particular command. Now, how we can also use the negative index to start extracting elements from the end of the series. So all what we have to do is just give the negative index -3 colon. It means from the last third element onwards, it will return the values. So rainbow -3 colon returns the last 3 colors which are stored in that particular series. We can also display the entire series in the reverse order. So what we just have to do, the series name rainbow colon colon and -1. Since there is no starting and no ending index is specified, we are what just specifying is the -1, that is to iterate one element in the backward direction from the end. So it will return from the end the colors one by one, and it will go up to the start of the series. Okay, now we can create. So in that case, in the earlier case, we created this series rainbow without specifying any index. So index labels. Now we can specify the index labels also. Let's say we create rainbow series and we are specifying the data as the colors, just like we did earlier. And now we are also specifying index, that is uh, VIBGYOR. Okay, so the output we get is a series which has the data like earlier. And if you notice, the index is not numeric this time. It's because we are specifying the labels of the index while creating the series. So we have VIBGYOR as the index values. Now in this case, if we want to just cross check what is the index of this series, we will say rainbow.index and it will return all these labels of this particular index. Now we can directly access any element using the index label. Let's say we want to access rainbow and the color whose index is of label V, then we say rainbow V, then it will return the violet color. We can also specify the index label as range. Let's say we say rainbow V colon G, it means return all the values corresponding to the index label from V to G. So that is from V to G, what we have is so corresponding to index labels V to G. Now, another thing to notice that G is not exclusive like in the earlier case because here we are giving the label values. So whenever we're giving the label values, it is included. But if we are specifying the index, then the value gets excluded, which is on the right side of the colon. So in this case, we are specifying V to G label. So V to G label corresponding to these, the colors get returned: violet, indigo, blue, green, violet, indigo, blue, green. Okay, now to access the element of a series in the reverse order, specifying the label names. So what we do is just the rainbow, which is the name of the series, and the last index is R. So we say go from R to V and take a step of -1. So it will traverse from end to the beginning with one negative index each time. Now, shape of the series tells the number of the elements which are present in the series. So it has 7 colors, so the shape is 7. We can also convert a series into array by using series dot to numpy. So if we say rainbow dot to numpy, so what we get in the output is just nd array, one-dimensional array. Now, if we want to check the data type of the elements of a series, we'll say series dot d type, just like we did in the nd array. So we say rainbow dot d type, it will return O, which is the object type. If you want to calculate the memory occupied by a given series, that is the total number of memory consumed by the elements of the series, we have to give the series and dot n bytes. So n byte is number of bytes. So this rainbow series is occupying 56 bytes. Okay. Now to make a copy, we'll specify dot copy function, and default method is deep equals to true. What it means, it creates a different uh, series objects altogether. So it's not like colors is pointing to rainbow, it's a different object altogether. So we say rainbow dot copy and we assign it to color. So colors is having the same data and the same index, but it's a different entity in itself. So if we compare the ID of colors and the ID of rainbow series, we'll get false. It means these two are totally different. They're not related to each other. Now, sometimes we get two series and we want to compare based on their indexes and want to apply some function on it. So let's say we have two series. One is the sales of 2020 and the sales other is the sales of 2019. So these are two series and they have some values, let's say four values, and these are corresponding to index A, B, C, D, and this is another sales, let's say maybe of 4 quarters or something like that, and corresponding to the indexes. So so first we are just printing these series. Now we want to find out for a given index uh, which of these series value has the maximum value. For example, if I compare A index of 2019 and A index of 2020, then which of these has a higher value, or a greater value? Then we'll see, okay, it has value as 20, this has value as 21. So the output in the output we should get, let's say, 21. So we can apply this kind of thing using the combine and specifying the function, what function we want to apply. So what we're doing here is sales underscore 2020, that is one series, and we are specifying dot combine. So we are combining it with sales 2019, and the function we want to apply is the max. So it will compare the values of both the series by matching the indexes, and it will return whichever is the maximum value for that particular index. So for A, it is compared 20 and 21, we get 21. For B, we get 6, and for compared, so we get 6. Similarly, for C and D, we get 7 and 9. So this is very handy feature if you want to compare two series based on the index and want to return the values either maximum or minimum. Another function is the map function. So map function, it maps the values of a series. Let's say we have a dictionary in which we specify ratings as 5 means excellent, 4 poor, 3 average, 2 4 good, 3 average, 2 poor, and 1 is bad. And let's say we have a series uh, called as brand ratings, in which the data is 1, 3, 5, 4, and some indexes are given. Now, if you just simply print this series brand ratings, we get this indexes, the indexes that we have specified here, A, B, C, D, and their corresponding values 1, 3, 5, 4. Now we want to convert these values 1, 3, 5, 4 into its equivalent string representation, like what is specified in this ratings dictionary. For example, for instead of 1, it should display bad. Instead of 3, it should display average. So what we have to do, we just have to up. So what we actually want is we want to convert, or in a way we want to map each of these values with its corresponding rating, which is given in the in this particular dictionary. So we have to, on this particular series brand underscore ratings, we have to do apply a map function. So we are doing map, and then we are passing the ratings. So what it will do, it will map function, it will take value one by one, and it will check whether this value is present in the ratings, and it will return the corresponding value based on this dictionary ratings. So A, B, C, D will return the value which is bad, average, excellent, good, based on the value present here, and when it gets mapped to this dictionary ratings. There is another method which is called as apply. With apply, what we can do, we can invoke functions on the values of the series. Let's say we have a series which has some couple of elements, and we want to just multiply each element by 2. Then uh, what we need to just do, simply with the series, we specify dot apply, and then the lambda function. The lambda function says that take each x, lambda x means uh, gradually it will start taking each element. So the first time value of x will be 1, it will be multiplied by 2, it will return 2. So you see the first value as 2. Next it will pick up the next element 2, it will be returned, it will be multiplied by 2, and it will return 4, and so on. So it takes gradually one element each at a time, then apply the lambda function on it, and whatever the output is, it gets returned. So the difference here between map and apply is, map, it's just like you are mapping the values with some other values, whereas in the apply we are kind of performing some sort of operation, mathematical or numerical operation, and then we want to return the result. There is another function called as transform. In transform, what we do, let's say we have a series and we want to apply two or more functions on it at the same time, then we can use a transform. So let's say we have two lambdas, square and cube. Square just simply doubles up the value, and cube just simply rather it should be cube, it should be thrice actually. THRIC, thrice, and it should, instead of a square, it should be double, yeah. And then we should change here as double, and it is thrice, yeah. and then we run it. So what we are doing here is we have just two lambdas, double and thrice. Double just simply doubles up the value, and thrice is to make it thrice. So on this particular series, we are applying this transform function, and within this transform function, we are passing a list of lambdas or other functions that we want to apply on each of the element of this particular series. So on this, let's say taking the first element 1, it is passed to double and the value gets double and it's returned here. Similarly, it is passed to thrice and the value gets thrice and it is returned here. So in this way, we can transform the given series into uh, this data frame where we can generate the values based on the more than one functions. Aggregate is another function where we are specifying an aggregate function. Let's say we have a series and we want to find out the minimum maximum values. So what we need to do, we just simply with the series we specify dot agg, which stands for aggregate, and then within the square bracket we can, if there are more than one aggregations we want to do, then we can specify within the square bracket. Otherwise we just simply give one. So let's say we want to find out the minimum and the maximum. So we say series.agg and min and the max as the function. So it will return the minimum and the maximum values of this particular series.